Okay, so the last lesson we did was just simplifying square roots and solving using square roots. Okay, today's lesson is going to be very similar to that, but now we introduce complex numbers. Okay, so last class, if you had x squared minus 4 equals 0, and I told you to solve using square roots, you would add your 4, x squared equals 4. You would take the square root, and x is equal to plus or minus 2. Okay? But what if instead of x squared minus 4, you had x squared plus 4 equals 0? Then you would subtract your 4, x squared equals negative 4. When you take the square root of a negative, up until this point, you would just have to say it was no real solution, which is true. It's not a real solution. You have what is now going to be introduced as an imaginary number. Okay. And with that does not mean it doesn't exist. Okay. It's not like an imaginary friend that doesn't exist. An imaginary number falls under the complex number category. So you've got real numbers and you have complex numbers. Okay. So a complex number is made up of a real and imaginary. If all you have at this point is something like this, that's a pure imaginary number. Okay. So here, we're going to figure it out in a minute. But when you take the square root of 4, you still have a 2. But now we know the definition that if you take the square root of a negative 1, that's I. So here it would be plus or minus 2I. Now, just because they're called imaginary numbers, again, those are a thing. If you go into electrical engineering, okay, that is, they use complex numbers when they're doing AC circuits. Okay, if you go into college and you do a degree with engineering, they used to make you do one class from each principle of engineering. So, like with my chemical engineering, I had to do electrical, mechanical, and industrial engineering. So, with electrical, complex numbers comes back. Okay, with mechanical, you can use complex numbers to evaluate the vibration of engines and to evaluate the vibration of bridges and things like that. You can even do it with some graphic designing software. Complex numbers can come into play. Signal processing has complex numbers also, so like Wi-Fi and communication between phones, that can, the people who control that, they deal with complex numbers. So it's not like it's just useless. Okay. So that's a little heads up of it's not pointless. It does have an application. So it's not just non-existent. Okay. So if we know the square root of negative 1 is I, what you need to look for is the moment you see a negative under the radical, you take that I and you stick it on the outside of the radical. Okay? That's all there is to that part of it. Okay? Now, if I were to take I and square it, that means I'm taking the square root of negative 1 and squaring that. What is the square root of negative 1 squared going to leave me with? Negative 1. So I squared is equal to negative 1. You are going to have to know these two by heart. When you take the square root of a negative, it's an I, and then I squared is a negative 1. Okay? So again, if all you had was something like a 2I, that's a pure imaginary number. When you have real and imaginary, that's a complex. Okay? So if all I'm doing is simplifying the square root of negative 25, that's the same as saying I've got the square root of negative 1 times the square root of 25. We know the square root of negative 1 is an I, and the square root of the square root of 25 is 5. So the way you write it, your coefficient or your number comes first, and then your I. So the square root of negative 25 simplified would just be 5I. Okay, remember when you're simplifying, you don't have to do your plus and minus. It's only when you're actually solving to get to solutions. Okay, now the square root of negative 108, that's not a perfect square. So I would take my 108 and I would do my prime factor tree. So that would break into 2 and 54. 54 splits 2 and 27. which breaks into 3 and 9, and 3 and 3. So I have a pair of 2s, a pair of 3, and a 3 left over. But I also have to account for the negative that's underneath that radical. So that 2 times 3 would give me 6. Then I pull out the I for the square root of -1, and then I've got square root of 3. Okay. Now, when you're doing multiplying like this, anytime you're multiplying with a negative, you have to simplify and take that I out first. Okay, so square root of -8, what could that simplify to? Mm-hmm. 2I square root of 2 times the square root of 3. So then when I multiply that, what would I get? 2I square root of 6. Okay, do we understand this? Okay. Now the next section, all we're doing is solving. It's the same steps. It's just now if you have a negative, you have an I. But everything else is the same. So if I have x squared equals -81, I've got x squared by itself, so I just take the square root, and x is equal to plus or minus, because you're solving, the square root of -81 would give me what? 9i. Very good. So then there's 3x squared minus 7 equals -31. With that, you would add 7 first. So 3x squared is equal to -31 plus 7. -31 plus 7 would give me. And then divide by 3, and x squared equals your -8. Take the square root, and x equals plus or minus what? 2i square root of 2. Okay? I want you to do the next one. Okay, what's your first step? Okay, so -2 times x plus 3 squared is equal to. And then, okay, so x plus 3 squared is equal to -24. Square root it, and x plus 3 is equal to plus and minus. And then your final answer would be so you've got to subtract that 3. Remember, it still goes in front of the plus and minus. So just like we did last class, you just now have that one. Okay? We okay so far? Okay. When you have powers of I, meaning I have I raised to any exponent, okay? there is a pattern that happens, and it's a pattern of 4s. So if I have I to the starting with the 0 power, anything to the 0 power is 1. Then I to the first is I squared we know is -1. If I were to do I cubed, I could split that into I squared and I, which is -1 times I, giving you -I. If I wanted to expand that and I'm going to do it right here, I to the 4th, I could split that into I squared times I squared, and that would give me -1 times -1, which is 1. Okay? If I continued I to the 5th, I could say, okay, that's I squared times I squared times I, which is -1 times -1 times I, which is just I. Okay? If I kept going, I would continue to have 1I, -1, -I, 1I, -1, -I. It goes in a rotation. It's a pattern. So instead of taking I to the 27th power or I to the 156th power and breaking that like I just did, there's a pattern and a rule that if you were to just take that exponent and divide it by 4, because it's a pattern of 4, and take the remainder, that remainder is your new exponent, and that allows you to be a simplified exponent that gives you one of these 4 answers. Okay, so if you don't know these, you're going to have trouble when it comes to your test. Okay, here's a quiz because you're going to have a quiz over this. So if I'm looking at I to the 27th power, I'm going to take 27 and I'm going to divide it by 4 and do long division because I want to know my remainder. So 4 can go into 27 6 times. 6 times 4 is 24, and when I subtract that, that leaves me with a remainder of 3. So that means I to the 3rd power is -I. So instead of doing all the breakdown for 27, you could simplify it to be I cubed, which is -I. Okay. If I do I to the 156th power, I take that exponent, 156, and I divide it by 4. 4 can go into 15 3 times. 3 times 4 is 12. When I subtract that, 15 minus 12 leaves me with 3. Bring down your 6. 4 can go into 36 9 times. 9 times 4 is 36. I have a remainder of 0. So I to the 0 power is 1. So all you are doing, making it easy on yourself, take your exponent, divide it by 4. Your remainder is your new simplified exponent. As long as you have this memorized, you're good. The pattern is very easy. You've got 1, I, and then you make them negative. -1, -I. Okay? So if I have I to the 78th power, I take that 78 and I divide it by 4. 4 can go into 7 one time. 7 minus 4 leaves me with a 3. I bring down my 8. 4 can go into 38 how many times? 9, because that's 36. 38 minus 36 leaves me with a remainder of 2. So I squared is -1. Okay. So up until this point, you had your pure imaginary. Now we're going to talk about our standard form of a complex number. Our complex number, you have a plus bi, when a is your real and your bi is your imaginary. Okay? Your real always comes first. That's standard form. All right? When you are adding and subtracting, you are treating that I as if it were an x. like it's a variable. Okay, you can only do real plus real and imaginary plus imaginary. Okay, so if I have 8 minus I plus 5 plus 4I, you're going to drop your parentheses and you really just have 8 minus I plus 5 plus 4I. You just copy everything down without parentheses. Then you combine like terms. 8 plus 5 is 13. Negative I plus 4I is 3I. So 13 plus 3I would be your answer. Okay. With subtraction, I drop my first set of parentheses, 7 minus 9I. But when you are subtracting a full term, 3 minus 5I, what are you going to do with the signs?
Flip them.
I'm going to flip them because you're basically distributing a negative. So I'm going to have minus 3 and then plus 5I. So 7 minus 3 is 4. Negative 9I plus 5I is a negative 4I. Okay, on this next example, I have 10 minus 3 plus 7I plus 4I. I've got parentheses in the middle of my problem, so I need to distribute something. What would I be distributing to the 3 plus 7I? The negative, not the 10, just the negative. So I've got 10 minus 3 minus 7I plus 4I. And that would give me what? 7 minus 3I. Very simple. Okay. When you are multiplying, okay, you would treat the I just like it were an X. If I did X times X, that would give me X squared. So if I have I times I, that gives me I squared. And then remember, I squared is negative 1. Okay? If I start with I, that's what you're looking at. If I start with a radical, you always have to take that I out as a negative 1, take the negative 1 out as the I, before you multiply. Okay? So here, if I just have 7I times negative 9I, that's going to give me negative 63I squared. But we know that I squared is a negative 1. So this is negative 63 times negative 1, which is a positive 63. Okay. Now, if I look at my radical, the square root of negative 5 times the square root of negative 10, if you don't take that negative 1 out as the I, you're going to miss the whole concept and you're going to miss a sign. Okay, so here, this is really I square root of 5 times I square root of 10. Then when you multiply I times I, you get I squared. Square root of 5 times 10 is 50. Then I need to simplify. We know that I squared is negative 1. And we need to simplify the square root of 50. And 50 splits 2 and 25. And 25 is 5 and 5. So when I'm writing my answer, I've got a 5 that needs to come out, and I also have a negative 1. So this is going to be a negative 5 square root of 2. Okay, are you good with that? Can I skip that example then? Because it's the same thing. All good? Okay. If I have 4I times negative 6 plus I, that's set up for me to distribute 4I times negative 6 to give me a negative 24I. And then 4I times I gives me 4I squared. Okay? That I squared is a negative 1. So 4 times negative 1 is what? Negative 4. I need to write my real part first. So negative 4 minus 24i. All that I squared does is change the sign of that term. Okay? So if I have two sets of parentheses, I need to do what with it? I need to FOIL it. So 9 times negative 4 gives me negative 36. 9 times 7i, 63i. Negative 2i times negative 4. Mm-hmm. And then negative 2i times 7i.
14i squared.
So this negative 14i squared is going to change to what? A positive 14. I'm okay if you scratch it out and make it a positive 14. Or you can just scratch out the I squared to be a negative 1. It doesn't matter. I typically do this. Okay? So then negative 36 plus 14 is going to leave me with what? Negative 22. 63i plus 8i is going to give me 71i. So negative 22 plus 71i. So then my next one, I want you to do. Did anyone recognize what happens here?
It's the difference in two squares.
They're conjugates. Yes, I know what you meant. So they're conjugates. You shouldn't have to FOIL that if you recognized it. What's your formula for conjugates? Your first term squared minus your second term squared. If you FOILed it, that's okay. The next section, we're not FOILing. Okay? So if you do your conjugate formula, your first term is 2 squared minus your second term is 4i squared. Okay, so 2 squared is 4 minus 4i as a whole being squared is 4i times 4i, which gives you 16i squared. And then a negative 16i squared turns to plus 16. 4 plus 16 is 20. If you FOILed it, you should have gotten the same thing. Okay. Now the reason I bring that up is because when you have a fraction, we're going to be using the conjugates like we did last time. Okay. So last class, if I gave you something like 5 over 2 square root of 3, we couldn't leave it like that. What would we have to do? You have to multiply it by the square root of 3. If I had 5 over 2 plus square root of 3, what would I have to do? I multiply by the conjugate, 2 minus square root of 3. Okay. The same rule is going to apply if you have an I in your denominator. Why am I not allowed to have an I in the denominator? Because I is technically the square root of negative 1. So if you have an I, then you still have a square root in your denominator. Even though it's not written, that's the definition of it. So if I have 2 plus I over 5i, this is similar to this. Here, the only thing that was wrong was the square root of 3, not the 2. So here, the only thing that's wrong is the I, not the 5. Okay, so what do you think I'm going to multiply by? I, because I'm creating an I squared, which is negative 1. So when I multiply 2 plus I times I, I'm distributing, and that becomes 2I plus I squared. And then 5I times I is 5I squared. And then I change my I squareds. I squared is -1. So 5I squared turns into -5. If I write it in standard form, I've got -1 plus 2I over -5. Can I leave it like that? Why not? I have to take care of the negatives. I cannot have a negative in the denominator, so I divide everything by that -1. And I have 1 minus 2I over 5. I no longer have an I in the denominator. I am good. Okay? You understand that? So if I have 5 plus 2I over 3 minus 2I, what am I going to multiply that by? 3 plus 2I. I'm going to do the conjugate. So my numerator, I have to FOIL. 5 plus 2I times 3 plus 2I. So 5 times 3 is 15. 5 times 2I is 10I. 2I times 3 is 6I. And 2I times 2I is 4I squared. And then my denominator, I take my first term, which is 3, and I square it, minus my second term, which is 2I, and I square it. Okay? Well, I know this 4I squared turns into -4. So 15 minus 4 is 11. Plus 10I plus 6I gives me 16I. Then my denominator, 3 squared is 9, minus 2I as a whole being squared is 4I squared. And that -4I squared turns into what? Plus 4. So I have 11 plus 16I over 13. And then I check, can I simplify? I cannot. So that would be my answer. Okay, do we understand that with the conjugate? Okay. So I want you to walk me through this one. What do I multiply by? 1 plus 4I. When you're doing your work, I've seen some people only do 1 plus 4I and not the fraction. If you're just doing this, you're not multiplying the denominator. So be careful. I will count off if you're not putting the actual fraction. Okay? So here, my numerator, when I multiply, is going to give me what? 7 plus 28I plus 5I plus 20I squared. Thank you. What do I do with my denominator?
1 squared minus 4.
Very good. So the 20I squared turns into, so my numerator becomes what? Plus. Very good. My denominator, what do I have?
16.
1 minus 16I squared, which is a plus 16. So I have -13 plus 33I over 17. Can I simplify that? Nope. That's money. Okay. I want you to do the next one. What do you multiply by?
1 minus 3i.
Okay, my numerator becomes what?
8i minus 24i squared.
In my denominator?
1 squared minus 3i squared.
If you can jump straight to that next step, that's fine too. If you can tell me 1 minus 9i squared, then that's okay. But I want to see one of those before you jump to 10. Okay? So then this is a positive 24, and this is a positive 9. So you have 24 plus 8i over 10. But that should not be your final answer.
Simplify it.
Divide them by
2.
and you get
12 plus 4i over 5.
very good. Okay. I want you to combine and apply everything we've done and attempt without the partner next to you. I want you to try to do this next problem. I don't want you sitting and waiting for me to write. I want you actually trying to do this one. Okay, for time purposes, I'm gonna go ahead and start. Okay? Even though it looks super complicated, it is not. The numerator, what are you doing?
Adding.
You're just combining like terms. So that becomes what? 15
plus I.
plus I. My denominator I have to FOIL.
Yeah.
So that becomes 3 minus 2i plus 18i minus 12i squared. Okay, so 15 plus I for the numerator. This turns into a plus 12, so 15 plus 16I. What happens is, people stop there. Why can I not stop there?
Are you supposed to stop?
You are not supposed to stop.
Okay, good. So.
You can't have an I in the denominator. You have to rationalize. So 15 minus 16I, 15 minus 16I. And then you have to FOIL the numerator. So 15 times 15 gives me
225.
15 times negative 16I.
Negative 240.
I times 15.
15.
And then I times negative 16I.
Negative 16.
Okay. And then my denominator, 15 squared is 225 minus 16I squared is going to give me 256I squared. Okay. This turns into a plus 16. This turns into a plus 256. My numerator becomes
240 minus 225.
200 what?
241
Minus
minus 225.
over
497. Right.
481.
481. And then you would check to simplify. When your numbers are this large, I'm going to show you a trick. Take your calculator and if you get a fraction, I don't know why this looks so blurry. If you just take 241, that's not what I meant to do. 241 over 481. If that simplifies, then that means I could probably simplify the other one. I cannot simplify this, so there's nothing left to do. Okay? Just because it looks hard doesn't mean it is. You just have larger numbers. Okay? So, real quickly, we got one more section. When you do the absolute value of just a number, okay, the absolute value of negative 10, that is defined by the distance negative 10 is from 0. And that's why you get a positive value, because the absolute value is distance, okay? So the absolute value of a complex number is the distance that is from the origin on a complex plane. So you're used to seeing x and then y, but on a complex plane, your x-axis is the real axis, and your y-axis is the imaginary axis. So if I had, let's look at the negative 4 plus 3i, negative 4 would be right here on my real axis, and 3i would be about right here. So if you wanted to find the distance this point is from 0, your distance formula from geometry would be the square root of x2 minus x1 squared plus y2 minus y1 squared. But we're not doing x and y. We've got real and imaginary. And if you're tracking it back to the origin, you're just subtracting 0 from your two values. So all you're doing is taking the square root of that negative 4 minus 0, which we don't put, squared, plus your 3 minus 0, which we don't put, squared. So then you've got the square root of 16 plus 9, which is the square root of 25, which is 5. Okay, this formula right here comes from what I just told you. When you take the distance formula, you're tracking it back to the origin, you're subtracting 0, so there's nothing to do. And you don't account for the I because I squared is what? -1. What's the absolute value of -1? 1. It doesn't phase my answer. Okay? So if I just have absolute value of -3i, I don't have a real part. So that's the absolute value of 0 minus 3i. So when I take the square root, all I'm taking is -3 squared because 0 squared is 0. So this is the square root of 9, which is 3. Should you have a negative as your answer? No. Why? I'm taking the absolute value, but you're really squaring everything, and anytime you square something, it is positive. Okay? So the absolute value of 3 minus 7i, I would take the square root of 3 squared plus -7 squared. So that's the square root of 9 plus 49, which is the square root of 58. Can I simplify the square root of 58?
No.
No, 58 is 2 and 29. So square root of 58 is all I can do. Okay? You have a quiz next time over this.